Good afternoon, everybody. Welcome to the Propeller Live Forum. It is August 14th, 1 p.m. Pacific. And before we start today's meeting, I want to know if anybody has any topics, any requests of any kind, support type questions, or things they want to share today, big or small.
No, I don't think I have anything.
I find that hard to believe.
Well, actually, I do have something, but it's like a very, very small thing.
Okay. All right.
But it might spark like a lot of talking. I don't know.
I put you on the small thing list. Okay, so today we will probably get an update on the PNut-TS compiler because we're ready to bring in some testers for that. There's a news article I published, which is right here on our website. My view of what we're doing, which I think is pretty accurate, pretty close. So you can go ahead and read that. I'll just put this into the chat when I can find the chat. There we go. Thanks for those who've commented on it so far. It's helpful. So before we go there, let's talk about next month. Next month, we're going to have Nicholas Benison back, von Deutschland, and he has used the X-Plane simulator output for a motion control system in his flight simulator. So he'll tell us how this works, and I think you'll remember him from his prior CNC presentation. So he makes precision CNC machines. So Nick, he was going to share today, but we had to wait a month. So we'll see him next month. Other than that, okay, so how about if we talk about PNut TypeScript? Chip, you want to just update us on where we are, Stephen? And then I would like to talk about how we could bring in testers to help you guys get your work formalized and done.
So we've got the thing, we've done a lot of proving. Fill in, Stephen, if I'm going to miss some stuff probably, but
Chip, hang on a minute. Before you go too far back up, since there are a lot of new people here that some of them may not even know what this is about, just remind us.
Okay, so
then tell us where we are.
All right, so Stephen Morocco has been spearheading this project where we're taking the compiler that is for Spin2 and which was written in 8386 assembler, and we're translating it. We're pretty much done at this point, but we got to add in the latest v45 when I finish it. But it will allow us to get out of the Windows thing and more easily run on other OSs and even web browsers eventually. So we've got it faithfully compiling every program we can throw at it, you know, possibly even replicating bugs that we don't realize yet, but it's super true to the 386 code. And we have it doing v43 of PNut now, which is just before the object release. But we don't, I'm working on object or these structures that were introduced in version 44. So that we'll make a 45 release, but we can't make a 44 release because I didn't arrange the code properly, and I had like a phase error between versions of stuff that went into the PNut public repository on GitHub. So then I started overwriting my work file. So we don't have the v44, but it's fine because things have changed direction a bit, and we kind of rethought how to do the structures, and we came up with like we're just going to do it very straightforwardly without pointers and things. So it's pretty much like how Spin works now, but you have byte word long, and then you'll have structure, which will have, you know, it's comprised of byte words and longs and arrays of them and arrays of maybe arrays of structures. Anyway, I'm working on that now in the 386 code, and then we will do a translation of all my changes into the TypeScript stuff, and then we should have a good version 45 with all of the final type of structures. Stephen, did I miss anything?
No, nicely said, Chip. And then where we're going next is I'm going to go ahead and over the next couple of days, after I think we've got one or two more files we're auditing to make sure our code generation is correct. We're running against large projects. The projects that I've done, we haven't run against everything in OBEX yet, but we're doing some large ones. And we've been finding a couple control structure issues and things like this that we're cleaning up. So overall, it's looking really good. Every time we found something, we fixed it. And so we've got one more that I want to look at, maybe two, and then I'll turn the repository public. I'll go ahead and release, and if I can share a screen, Ken.
Yep.
My gosh, where are we? Okay, let's just share the entire screen and hope I'm in a good place. That looks pretty good. Okay, so way too many things on screen at the time. Let's do this. First of all, when I release it on the releases page, you'll see things like this. They probably won't be exes, but you'll see then one of these executables for every platform, and they'll be zipped up. And they'll be repackaged a little bit differently than this, but basically you'll download a zip file for your platform, move it into the install location, and then you have a new command line compiler similar to FlexBin in terms of how you interact with it. So ignoring that for a minute, command line looks like this. Moving this window around, this is our command line with options. It has a build date just like FlexBin does, and we'll be releasing it at 143 initially, and then 145 when we get the 45s in. 143 we'll use for asking for a little bit of community help to run things and compare against PNut, run their projects, compare against PNut, the listing files and the object files and binary files, and make sure that they like the changes, that it's matching correctly. Just for a little extra checks, we fully completed coverage testing, but as we know, coverage testing can't test all the built-in table searches and things like this that we're doing, and so we're still running a lot of comparisons. Everything that we find, we're adding as a regression test, so that everything we find that's not matching adds as a regression test, and I just saw John's question, and the answer is yes, John. It'd be a command line for every OS. Sorry, I distracted myself with chat. So where was I? I distracted myself. We'll be opening it up for testing. I'll create a release page for 143. You'll download the version you want. You run, test it against your code, compare the listing and binary files that are generated, and we want them to match. If you find anything that doesn't match, then report it to us, and we will take that code, chase it to resolution in the compiler, and make sure that those fixes are in the compiler before we release it. So that's it. This is our command line. There's a couple extra diagnostic things in here which you don't need to care about, but this is the dominant command line form. Let's go over here and look at this compiler. Now has a preprocessor, and those of you who have read the FlexBin documentation will see that this page is pretty identical to FlexBin. Thank you, Eric, for putting that together.
Preprocessor.
So we have a preprocessor that's working. We have define symbol, undefined symbol, add, include directory. And then if you want to dump out what the preprocessor is actually handling to the compiler, you can specify a -i, and it'll actually save it as a -pre file with your base name. So you can actually see how the preprocessor is working and if it's doing the right thing. Conditionals are supported, are nested. Nesting support is here for conditionals. And so it's basically the full set. We also define some internal symbols when you compile. So that's there. So that takes care of that. That takes care of this. And I think that may be all the additional information I want to show. This is not what it's going to look like. These are the input files to my packaging mechanism. And basically what we get when we're packaged, that package is dist. I'm not in the right place to show it to you, so I'm just going to ignore this. I have lots of files all over my machine. I think that's it. With respect to VS Code support and Visual Studio, IDE, I will be releasing, at the time I release the 143, I'll be releasing the extensions to Visual Studio. These extensions automatically detect if you have FlexBin installed and will automatically detect if you have PNut-TS installed. And you can select then which compiler you would like to use by project. And so if you want a certain compiler to be defaulting to FlexBin, a certain project to be defaulting to FlexBin, then you can select that and it'll stay in your workspace settings. If you want most of your things to be done by one compiler, you can set the global setting. And then if you want to override that for certain projects, you just set the project workspace settings to override it. Auto tool location, installation location is there. Download, compile and download with either compile is supported by Visual Studio IDE. And so that should work pretty well. I'll make sure that's released at the time we're asking for testing help, so you'll be able to use that as well. I think that's pretty much all I have. Here are the READMEs from the reimplementation repo at this point. This repo is not the one that's going public. This is my private one. It'll look very similar to this.
I have it off.
Oh. They have it off?
Well, I turned it off. I can turn it on.
Well, I moved.
Okay.
Carry on.
No worries. So here's the command line reference I just showed you, preprocessor reference. This is a repository if you actually begin to want to look at the code and build it. This runs in, I'll be describing that it all runs in a Docker container, so you can download it to whatever platform you're working on and actually build the compiler, run the regression tests, and all of that is available. Let's see here if I can show you. If I go here, and we go to LCOV report, and then we go to this. Oh, great. Of course, in Git, it doesn't expand the web page. Fine. Fine. Anyway, I was going to jump into the page that shows you the regression status. Ignore that. I won't do that. It's just not going to show it in the repo the right way. The net result is once you clone the repository, you can actually look at the coverage report, see how we did. We're in 90s for all the critical files at this point, 90% branches, statement, and things like this. So we're in really good shape. And I think the only thing missing now is making sure that we do a suite of tests for all of the exceptions that can be generated by the compiler. And that'll happen over time now. That's not going to be a critical path for us releasing. So I think I'll leave it there. Does anybody have any questions then?
I have a question. Okay,
Sure.
so if you don't want to use the command line to do compares of PNut and PNut-TS is the easiest way to use Visual Studio Code?
What I'll probably do when I invite testers is I'll have a page, hopefully with some tool suggestions on how to do diffs and things. Generally speaking, it's probably easiest from the command line on all the platforms. You can also, yes, I've got an extension that actually does a hex diff for Visual Studio Code. And of course, the listing is just a listing comparison. And I'll make that available when we ask for formal help testing.
Okay.
So that'll be there when I do the release. So we are happily very close. We're excited with the behavior of it so far. It's doing really well. Gosh, I'd love to wrap this up and make it generally available, but it'd be wise for us to do some wider testing first before we call it good. So that's our approach.
Well, nicely done for the past 8 months.
Yeah, it's been some work. But now we'll have an open source reference. The repository will be public. It is MIT licensed, as Ken says in his post that he wrote, and it'll be available for everybody to peruse and use as they wish, I guess.
Yeah, we'll be putting the Spin2 interpreter out, which it is already out, I believe.
It is
right, Chip?
already out. Yes,
So-
we distribute it with PNut. Yes.
So also put the MIT license on that, and then we'll put the P2 on the Open Source Hardware Association page in case people are interested in that.
Nice. Nice. Anyway, thank you.
Thanks, Stephen.
Thank you, Chip.
Any questions or comments for either of those two? This is a long work in progress, isn't it, Chip? I mean, we've been wanting to get
Yeah,
to this point.
we've been at this for like 8 months now, and getting back into the compiler. I mean, the work I was doing with structure, it's taken me a long time to spool back up to where I left off. I didn't have anything displace the knowledge, but it just faded in my head.
Yeah. Yeah, I think we had a couple fun things happen in that apricot season came and distracted us for a month, and so it's probably only 7 months, but still. And then I think I've mentioned this before, it served as a really good opportunity to validate a PNut as well. Literally
yeah.
line by line validation, so for both of us.
Yeah. How many lines of code do you think we've written, Stephen? Do you have any?
Oh no, I don't even have it started right now, so, but I'll post
still
that.
have that one little
publish it.
script? You
Yes, I
had
do.
one little script that you'd run that would say it. Stephen typed it all, but we worked on it over Zoom.
Yep, it's been an effort. I don't know how quickly I'll get it. I'll see if I can get a number here for us sometime.
The coverage
we should
testing
also-
he was talking about, in case someone's not familiar, it's kind of a new thing to me, but the coverage tool analyzes every branch that was taken, every condition in a ternary, and it shows you how many times each has been executed in the course of running all of our test files. And anything that hasn't been executed at least once, we have to go in and create code to exercise to make sure we're getting the same results as PNut.
And so we have an automated framework. We add the files and the golden files from PNut to the regression folder, and then every time we change the compiler, we rerun against everything in the regression folder. So we're upwards of 90 or 100 files now easily, testing everything. Some of the files are kind of fun because you wouldn't want to compile it and download it to the processor because we're doing breadth coverage of some of the language. But a lot of it is real code with every feature of spin that we can imagine being tested. So it's turning out really good.
Well, actually, so many of our community members too, through the years, have filled in when we've not done a good job getting ourselves to other operating systems. Eric Smith, and even going way back with the basic stamp. Murat Konar, who made it work under the Mac. And Microsoft's, so I think he has his own compiler too.
I have a quick question. Will this run on the P1 and the P2?
Negative. This is P2 only.
Okay. Fair enough.
Hey, Stephen,
Yes.
have you thought about making all this work for P1?
It would be a smaller effort than what we did, but it's probably an elementizer and some replacement tables, and the rest of it is pretty close.
Yeah. It'd be similar.
Yep.
Well,
And
there is
so-
What is
already
already OpenSpin.
open spin. Exactly what I was going to say. Yeah.
Thank you.
Also, the FlexSpin P1 bytecode backend, if it's not bugging out, and I am giving you my personal thing that for normal spin code it shouldn't, then that's actually a lot better than what OpenSpin even does, because it gives you extra features and it has better code generation.
You're talking FlexSpin does.
Yeah, the FlexSpin bytecode.
Yeah.
With you.
Like that can also, if you really want to write C on your P1, but you don't want like the C bloat or making it all large memory model, then you can just compile it to bytecodes sometimes. That doesn't always work because there's some constructs that can't be represented in spin bytecodes, but a lot of things can. It's very interesting.
Hey, are there any metrics on like going from compiled ASM down, or what compiles into PASM code versus bytecode? Is there any kind of metric for what the reduction in size usually is?
Many, I want to say. But that really depends, I guess, on how much of your program is actually code and how much of it is just data.
Oh yeah, of course.
Because usually it counts the static data with the code, so it's a bit hard to figure that out.
So maybe someone can answer Terry's question in the chat.
I got it. I'm working on it now.
Okay, cool. And before we leave behind PNut TypeScript as a topic, I'd like to get any input from anybody on what kinds of uses you might foresee with it for web-based programming, so that we can have a friendly little contest in which our community develops some sort of web programming solution in the browser that does not require any installation anywhere. So that's possible with this, I presume, right? Stephen, Chip?
Stephen would know better than I. Yeah, I think it should be. There's still like file
Right.
issues.
So maybe more for those who might see interest in web programming. If that's of interest to you, how would you like that to work? What would you envision there? Just something really simple, or like something like an IDE, proof of concept? Would anybody use it? And if not, that's okay.
I think it would kind of have to be somewhat of an IDE because we'd need some facility for bringing code in and running it through the compiler.
Well, the Visual Studio Editor, Monaco, runs in a browser, so that would presumably be a good place to start.
Yeah, just slap some Monaco in there and then just like the problem with doing it in the web browser is that you don't really have a reliable place to save things to. Like there's like this local storage stuff and stuff, but that stores to like God knows where on your computer. And sometimes the browser will just delete it because the user hits delete cookies, and somehow that includes all the stuff you stored in the browser. So that's kind of the problem. You have to sort of, hey, you must save this manually to your hard drive, otherwise it's gonna get lost.
Like upload it.
Yeah, either have to like manually save it, like download it onto the or you have to store it on a server somewhere, which is obviously undesirable.
Right.
So VSC Monaco is a likely solution for web-based programming, huh?
Wouldn't you want to build a web browser first?
Well, I don't think we should build anything that doesn't need to be built if it already
Yeah,
exists.
you'd be using Chrome or Firefox
Mm.
on your PC, or
Yeah, right now, when you have, if you take a look at the IoT gateway, there are examples there of using a web browser to remotely control an application on the P2. And that has controls on web pages that you construct by writing HTML source. So a compiler would be very similar in the sense that you'd put up an editor field, paste in the source, compile and download just by pressing a button. So that kind of thing can be done if it's found to be useful.
I think a lot of it depends on the application, like this particular thing, which you're familiar with because we use so many of them, the microbit, the market being education. The fact it runs in a browser and requires no installation is pretty much a #1 requirement of any school and any IT department that manages any computers in any school, because they can't put anything on their computers.
Well, then
So
someone has to have
it's
some server with all kinds of stuff to protect potential miners from right?
Well, I think a lot of the requirements are more like not having any login information or any passwords or student information, but not being able to install software is a big requirement.
Mhm.
Yeah, we're gonna teach them how to use computers, and we're not gonna install any software on the computer.
Yeah,
Just
sometimes
like
the teachers will
Kind of a
get
curious
computers.
requirement.
click around in MS Paint. That's gonna be
Y-
that's the computer education now.
Yeah.
So secure they can't use it.
Yeah.
For the web application, wouldn't the high level wouldn't at a high level wouldn't it just look like an application that you log into from a web browser, be it Chrome or whatever the user has, which just serves a web page which allows you to type in some code. So a rudimentary kind of IDE which could extend the Monaco project or something like that already exists. Just have the compiler built in, which it could do now, as I understand it, with the PNut-TS, and then just have the option to save it to the SD card that's connected to the Edge module, or save to a cloud account, or even save to the computer's local account if they wanted. And
I mean,
perhaps
just
and
saving it to
perhaps
the
not much more than that to
saving
start
it
with,
to
at
the
least.
P2 itself is actually a really interesting idea.
Well, because then you can use it offline. So I think it would be important to be able to do that. But I think also having the button in the web browser just to, sync or save somehow, and also load from a cloud account, I think could be also useful. Down the line, also you could sort of load in examples from a cloud account, which you could then modify and save locally. So I think anyway, at a high level, that functionality for sure, load and save to a local SD card. Because that technology is already there. Yeah, cloud
How do you,
access.
the problem with any of this web-based thing is, how do you get the Propeller on the school's internet to begin with?
Doesn't need to just plug it into the USB port. There's something called the Web Serial API, which is a very funny name, but you can use it to make the web browser talk to a serial port.
Yeah, that's great. You're getting around the whole network problem at that point. But once you've got a cable into the device, you're no longer navigating networks, which is good. But if you're cabled in directly, why not? So you want to do it over USB, but you don't want to have software. You don't want any proprietary drivers required, which is, you probably already almost have that.
You're probably always going to need that unless you use USB HID. But I think as long as you stick with FTDI or the CP, whatever the two common ones, I suspect most school districts would have that installed on their systems, would they not?
I mean, the primary case here is probably something like a Chrome OS thing, and those are basically just bootleg Linux, and they just have all the drivers built in.
I've never had to install a FTDI driver on anything, on any operating system. They just work.
Putting that to one side, though, I think the absolute beauty, of course, of wireless is that you don't have to worry about any of these drivers, as long as you can just connect to the AP, but it's the IP address of the Propeller 2 module acting as an access point. But then I guess that's a usage thing, isn't it? Do you want the students to have one Propeller each with its own IP that they just connect to from a tablet? Would that expose issues to schools? Each there'll be a bunch. Each Propeller 2 would have its own unique IP, and the kids can just connect to it as an access point, open password. That would be relatively simple from an IT standpoint, but whether that violates any access protocols, I don't know.
Maybe you have like a jump box where you have a a Raspberry Pi in the classroom that can talk to all the different bots, and the kids can share them, because as you say, you don't know whether you've got one bot that's shared by a group of 3 kids and they all want to test their code, or
Yeah. Well, there's a few ways of doing that. I don't think any of them are particularly complicated, but it just needs to be, yeah, it just needs to be, definitely need to know what the classroom needs for sure. Because there's the, there's that other aspect that the teacher might want to be able to kind of, log in and override or oversee what's going on. A bit like a learner driver. The driver, hopefully the teacher's also got control, with his steering wheel, or at least his brake pedal. Whether you want each student to log into their own unique IP to their own address, and then a teacher to also be able to connect to any of them at any time. That's where having a common network thing would be kind of handy. But then you get into networking, so maybe that's an issue for schools. Can't each classroom just have its own little wireless router, though, which would then be separate to the school's network and perhaps obviate all those issues?
You're too creative for the educational environment.
I mean, it could be, to be fair, it could be done in software with the with the ESP modules as access points as well as clients. It could easily be done, but it's just a software effort which is only worth doing if you understand the need. But I think for the first step, I think having essentially a small web page which you can log into with the Chrome browser, and the device itself just exposes an IP address, or you could put the credentials on the SD card in a text file, so you can you just plug that into each Edge module, because they have the SD socket, and there could be a text file that is just your IP address, SSID name and password if you want, and then when you power it up, the student can just connect to that IP address and be given that username and login, and that's done. Then that's all the configuration done for you. And then just connect to it with your tablet or your laptop. Could be a Chromebook, doesn't matter. Could be anything, as long as it's got a web browser. Connect to the thing. Have a rudimentary IDE, as Chip mentioned. It could extend the Monaco thing or one of something like that, and then compile on the chip and then download to the P2, as we do already. Just have the option to save the file back to the SD card, and possibly upload and download to a cloud account as well. And that's pretty much the basic sort of starting off set of requirements, isn't it, really? And then you could extend from there. You could connect to a page that has, a load of example spin files that you could also download and edit locally, and it kind of goes on from there. But the basic to get you going stuff is that, isn't it? As just said.
So could you make it as like an ESP32 coupled with a prop clip, where you could sell a wireless programming cable, and it just would host a local open wireless access point that you could get to with your browser and drop files in? And I mean, aside from education, I mean, do I want one for my hobbying?
Well, the way it works now with the sorry, Terry. I was just going to say the way it works now with the Parallax Wi-Fi module is exactly just like that. You just go to the web page with your browser and just drop your spin files into it, and it'll upload them to the Propeller 2, and away you go. So the wireless program already works exactly like you've just described. But what it doesn't have is the option to compile as well as upload. It just gives you the uploader.
But that could be separated, where you have a compiler produces a binary file, and then you upload it through another separate process. It helps teach kids that there's more to it than just running a program. You maybe got a pilot, and compiling it and loading it is 2 separate steps.
Yeah, well, I mean, I think you'll find the example of how to do it I think there's a step-by-step guide on the QuickBytes page, or at least somewhere. The Parallax Wi-Fi module connected to one of the Propeller boards, the Edge module or the eval, and then you just configure it as an access point, I've shared code somewhere to allow you to put credentials on an SD card for configuring the thing.
Well,
But there's
Blockly or the badge, the parallax, not the badge. How am I mixing up with the little
Yeah, there was a
Blockly
way-
plop on the little black badge there? That does a very elegant job, and that's mature technology.
yeah, I wrote that, so I know that well. Yeah, exactly that. That allows you to upload and save a number of compiled spin files to the badge, and then using the badge menu, you can choose which one you want to load. And through the badge, as you know, you can enter the credentials that you need. You can search for the access point, you can select one, enter the login credentials, and it stores it all in the badge memory. So it would kind of want to work a bit like that. You're just using what the Propeller 2's got rather than the badge, which was custom made for that purpose.
So in
But
the
as I say,
application sphere, you're really set on trying to have a compiler and a loader in one, accessible from a browser.
yeah, I think that's the thing, because then you avoid having to have a USB connection, so that you don't have that fuss for education. Because this is all about, ultimately, I mean, I know there's obviously a commercial use case for this as well, but in education, it's all about making it as simple as possible, plug and play, no headaches for the teachers. And obviously USB cables, just the cables themselves, let alone the drivers, is often a headache. And so, yeah, having a system whereby anyone who knows the IP address could connect to it, and then have a programming interface come up into which they could type code and possibly load code from a cloud, and then save code to the local SD card, which is built into the Edge module anyway when you're finished, and then go home and work from home. Perhaps you wouldn't even need internet once you've got some code on your device. You can just load and save it from the SD card and continue developing it in your browser, perhaps from your iPad, or similar tablet. So you don't even need a computer once you've got a browser connection. So it does make it a bit more versatile, I think, a lot easier to use for all users, and I think that's the ultimate goal. And we kind of had that technology now, but what we don't have is the ability to, once you've typed your code in, to actually compile it on the device. So this is why the PNut-TS is a really big step forward, because thus far we could do all we've described, but you would have to program the code in a Propeller compiler on a device, a Windows device, let's say, and then save a binary file, and then copy the binary file, or through the web page of the Wi-Fi module, and upload that to your device. So this allows you to work with actual source code on the Propeller device directly. So that's a big leap forward. But essentially, it's
Sorry, I don't think the PNut-TS is going to run on the Propeller device itself.
Well,
No,
it would
but
run. No, it would run in the
you would
in the
serve it to
wireless
the
module.
browser.
Yeah, exactly. Yeah, the code would be hosted in the wireless module, and then it would serve to the browser.
Gotcha.
The way, Ken, you know this, the microbit, the way it handles this stuff is you have to have an application loaded that's running on the host system, right? And then it uses like USB, but it looks like a storage class device, right? You plug the
actually, I backed
microbit
up on
in.
that. I don't
What's
think there's
that?
anything. I don't think there's anything on the host system to use it.
Mm,
It is just a
okay, you
storage
drop a
device.
file. You have to drop a text file into it, right?
Yeah, and then the microbit has has the interpreter and the means to manage that text file.
Okay, so it looks like a thumb drive or something. You drop a file onto it, it takes that and interprets it. So then what do they use to compose the source code? Do they just use Notepad or something?
Just a web interface editor.
Oh, okay. Yeah, it's called what's the name of it? I remember seeing it.
Well, there's
It's
a
like a
couple.
one-syllable name, right?
Yeah, there is. Well, you could look them up. So one is just go to microbit.org. That's one, and then the other one is Moo, right? Isn't that the name of it?
Yeah.
MU editor.
Moo. Yeah.
Yeah. Which are both web-based. Wait, Mu's an install. I stand corrected on that. But I guess we don't have specific plans to put the P2 in education that way, but I was interested from the perspective of what the possibilities are for online compiling and programming, and if we want to be pushing that, because depending on the application, like with the microbit, it opened up a massive audience. And suddenly educators had to get no approval from any IT department or anybody. They just had to have a computer that can connect to something via USB. And this has just only gotten more and more restrictive in school. And I'm filling out paperwork all the time, every time we sell something somewhere, about what data we collect, which is nothing, in using the microbit, and how the system works. So teachers can't even go to a location without an IT department contacting the vendor or supplier of the software for details on how it works.
You're gonna have to buy some insurance policy, right?
Well, yeah, it keeps going. Yeah.
Is there any interest in Parallax hosting a web?
We've done
Internet
this
available.
for, I know where you're going. We did this for Blockly, right?
Yeah. I mean, it gets gross because you don't want to hold people's files forever. It was some little temporary thing, and then they come back 2 days later and you say you didn't save my files, but that you can't store your code locally. It just generates a binary file, Propeller, compiled for the microcontrollers that you make. It's just an online compiler because the students have access to the internet. And if the compiling could be done off-site, you could keep your compilers up to date and there'd be no local storage of any code. That could be useful. They could just drop a text file in, compile, get the binary back, and then load that through some other means.
Right. In that system you're talking about, we originally did store files in the cloud and on our networks, but that was really not allowed. So then we made a version where they can store locally, which is now the only way it works. But
Yeah, security is always going to be an issue when you're talking about something like this. And you've got to define what an architecture of the educator's facility, what architecture they can use in order to maintain security, to prevent people from doing things they shouldn't do. So if somebody wants to store something from their device, they need a way to do that. And you'd have to give them examples of how to do that. So they store everything locally, not on the internet. You want to keep them away from the internet if you can. That will, if you can do that, that improves security quite a bit.
Yeah, I seems so to me too. Less is more when it comes to getting inside their system.
Yeah.
So has anybody used the BeagleBone? So that has a USB connection, and when you plug it in there, so like you get like 3 devices or so, where it's a USB serial, mass storage, and virtual Ethernet device. So I think sounds like they have a similar setup going on there.
Nice, because once you mount to the storage device, there's files on there, a live web page that you load up and can twiddle like the LEDs and twiddle the IO and reconfigure the device through the web page that is served up off of the device itself. It's not a web server on there really, it's a static file, HTML, but it's got everything jammed in there and is quite useful.
I think that's how we expect this to behave as well, that the wireless module, I mean, the Parallax Wi-Fi module currently uses an ESP, but it, it could be something else, doesn't matter. But essentially the wireless module would hold some HTML files and a bit of JavaScript, which is served to your browser. So you wouldn't need an internet connection or a school network connection at all. You just need to connect directly to that Wi-Fi module, and away you go. Write your code, save it to the local SD card. You never have to touch the internet. And maybe that takes kids back to the old school when we used to get a computer magazine and lines and pages of code and type it all in and play the game once, and then when the thing powers down, start again. But yeah, I mean, it's certainly secure. I mean, it could be as secure as you want, but then of course they'd have the advantage that if their mobile device does have internet connection also, then they could also then download example codes or parts of codes, to get them started from an internet site. Or the teacher, of course, could preload the SD cards with a bunch of files that they want the students to work with. And with the Propeller too, we could create an SD card loader, so they could plug 32 SD cards into one, P2, and batch preload them with the source code for the lesson, and then just give each student an SD card as they walk in the door that's preloaded, ready to go. So yeah, it could be a very nice system that doesn't rely on the internet.
Store some of those ideas, Michael, and we'll talk more about them offline.
Yeah. Incidentally, just for Ted, I copied to the chat a couple messages back a link to a previous wireless programming example. It's 2021, so obviously, it might not still quite work that way. It's improved maybe or changed slightly over time. But anyway, just to give you an idea of how it was working or how it currently works.
No, it's all beautiful, and it also requires the student to have, if it's a desktop with no wireless in it, then they can't necessarily connect to that network, or maybe they don't have credentials to change what device they're connecting to wirelessly. And when they do that, then they're not on the internet. So they sort of have to bounce between networks. It's easy enough for us because we know how to do it. But I think about some budding teacher that keeps butting heads with IT, and
you can see an issue of, we hook to an access point one time on our one device, but you do that, a dozen people turn on their access points all at once and try to discover them. I think that'll be a trick and a half.
Yeah, there is some stuff there, and definitely that's exactly what we need to understand, is how to replicate that how that happens in a classroom, and where those restrictions are for students and teachers, for sure. I mean, what you've just mentioned is really interesting.
What I see here, a lot of kids carry Chromebooks around in school. That's kind of how the whole thing works. Chromebooks all have wireless access.
Yeah, but if they can't, what would be interesting is whether or not the students are allowed to change the access point they're connected to. If it's locked down that much that they can't even do that, then we need to come up with a solution that works.
Yeah, that would be the kind of thing that would be locked down too.
It is what you imagine, Michael. And what Ted said.
There's always another way, but we just need to understand what the rules of the game are to come up with the other track to run down. Anyway.
Yeah, so if we revisit this, we need to define what the real objective is.
Absolutely.
The requirements of these teachers.
Yeah.
So how about if we pause on this topic and see what else might be shared today? Shannon, I think you had some...
Yeah, I had something to share here.
Solar, brushless motors.
Well, it's a little more mundane, but fabulously more productive and revelatory for me here. So,
okay.
I fell in love with the I/O of, the flexibility I can have, like was just mentioned, and I think about doing, 16 SD card burner, all at batch burner, through a P2 or something like that. And I talk about things with lots of serial ports, but anyway, I build I built projects, and yes, doing the motor control and the boxes, the things that they go on, shake and shimmy, and it's a physical rough world. And I'd been spending an inordinate amount of time trying to get the connection from the without building spinning up a whole new board just for this, but using the P2 edge slots sockets the way they were, how to get a good physical interface to the outside world and get this thing protected in a compact and reasonable way that I didn't have to invent every time. And honestly, the card sticking up like that, it just was gangling out of place and took me forever. And I've been getting into PLCs lately and looking at the enclosures for those devices. And I'm putting these two pieces together here, and I don't know. I have to think you all have been hiding this on me or something. Because that fits with its extra boards and everything, fit exactly into a pre-purchased, pre-made PLC DIN rail mounted box. And
yeah, that's accidental. Accidental.
It was just so dead perfect. I thought, okay, somebody's hiding this on me. But anyway, let me share this now. The secret's out. This is a pretty reasonable way to do things now. And I've been spinning boards with the P2 edge slot in it and my own set of connectors. But now I'm finally realizing that I can take what I might have made on the bench with just one or two of these and encase it in a package that is easy to package in a way that has a clean, sturdy interface, all professional on the outside, and lets me do something like this. These boxes, this is a $15 box made for breakers that mount on DIN rails. And all the pieces here are easy standard things to buy, punch holes, make a good, clean, solid interface. I've got a Nextgen display behind here that, well, I can't touch it through here, but you can pop the door open and it just makes a great, compact, solid interface device that I don't feel bad installing down next to my boiler or in the garage or wherever the project comes up for me or other people. And I even went old school DB9 on there. The full size board fits well in there. In the larger boxes, there's all manner of size of these boxes, different widths, and I don't have any right now, but well, I didn't bring up to the table. I've got on the bench. You knock these pieces out and put in a breaker and a relay and a power supply, and you stack up other tested, proven, heavy-duty devices right in here to interface. Well, I'm not showing you too much right now, but and the effect is you end up connecting things off of the board you've got in there out to external interfaces and or adjacent relays and power supplies and stuff. And just in the last month, once I realized this, it's turned my world around here. Now things are moving at a much faster clip than they were before. Knowing I can find a robust piece to interface the P2 with the world and keep it in a good weather-tight enclosure and everything.
So Shannon, that last box actually showed us a DIN rail in a box then. So you
Yeah.
can combine multiple pieces.
Yeah, there's a DIN rail in here too.
Interesting.
And you can get them down to, well, too small for the P2,
Right.
but there are some that are like this. What I held up is a 15 wide.
Right.
You can have two of these stacked in a single box, two DIN rails and two lift up doors and whatever you want, whole stacks of heavy relays or whatever.
Can you share links to some of those boxes? That's very cool.
Sure. I'm just picking them up on Amazon. I can well, I don't have them all here, but I'll post something. I'll post in the forum a whole batch of all these DIN rail parts and boxes.
That'd be wonderful.
Is that a
It's a
micro
fun
SD
find.
card sticking out the top?
Again?
Is that a micro SD card sticking out the top?
Yeah. That there is the full size P2 board under here, with all the headers on it. They don't honestly line up quite exactly as good as the others, but close enough to be serviceable for sure. As is.
Yeah, just like or like I've broken two micro SD cards in similar situations. You know, one being on the edge.
Yeah. I don't. I'm wary of that. Yep. Thanks.
Question for you, Shannon. So on the accessory boards, like I saw an RJ45 there, and you talked about relays. Are you designing those, or are you using off-the-shelf parts for that too?
I am going with I'm kind of standardizing on serial interfaces. Power ground RxTX in a, so that's in the board, right? And there's screw terminals on here. You screw the wires in, and this might hook to the external connector, and then you can do your connections there and press it in. And that's an option for some. Lots of the DIN rail mounted stuff have them so that you can wire them up and know that you can easily pull things out, move it around, and get things back in the right slots. There's that option. So I'm effectively making now these little add-on cards, but stacking 2 ports or getting more creative on that, and alternately, if things aren't expected to be moved around as much, there's connectors like this that I find work better, actually better than the screw terminal ones, and they're the same price, spring mounted. And the wires in between, there's little termination reinforcement ends on them, so you can in and out them a lot, and they make good connections, and you don't worry about frayed off little wires and stuff. So yes, I'm making now boards in this or slightly wider, or maybe 2 at a time, interfaces with, again, lots of pins, well, the boards that could receive either of these. And the pin spacing allows me to get creative and populate it with, these are through hole, you know, I solder them up when I do a thing, and I can put the right connectors on that I want at the time. And that's
just-
that
The way
4-wire kind of interface. And in the PLC world, they have a lot of 485, RS-485, but honestly, you can actually screw in here either a Bluetooth wireless serial right into these pins, or RS-422 with full RxTX long distance interfaces for, but still have effectively the same interface board to the P2.
Shannon, are these the kind of boxes you're talking about? It says Bud. I just-
Yeah, there are some like that, and I've got bunches like that that I hadn't considered putting a DIN rail in. Yeah, and each of those had become one-off sort of things, and I never found a good way to make use of most of them, except I've also got a bunch of little ones where I might end up putting a bunch of RJ45 to RS-422 interface, and plug in and footprints for your variety of Arduino footprints. Does lots of sensors. Every new sensor that comes along I can't create a driver and spin that fast, and you all are doing a heroic effort to give us drivers for new things, but frankly, you get a $2 Arduino, and that comes with a new sensor, which comes with a sample code to do a little hello world right on there, and spit out your data on the UART interface effectively. And so encapsulate all that new driver and Arduino stuff at the endpoints, but consolidate everything is kind of my direction, all on UART interfaces at the P2. And I've been playing an awful lot recently, Stephen, with your 8-port, all your 8-port spin code, and seeing if I can squeeze 16 out of it. And I don't need 3 megabaud, you know, 115/200 is ample. And I think I can do that. It looks like from the code, I can do that 26 times, and probably 24 times is enough.
Very cool. Glad to see that it was helpful.
It's hugely helpful. Thank you.
Seems
And
like you're able
yeah,
to focus, Shannon, on what you're really productive at and get your projects done more quickly this way.
and I hope others can get their stuff in a box, and that's the last, you know, it's fun, code, electronics, bench. That last seemingly 20% of putting it in a box has been taking 80% of the time, and slows things down. And now when I button this up, I wouldn't feel bad giving that to a client.
Yeah, the reason I went out and got these, Doug's using these for his projects, but they found a supplier. They're getting these things for like, I think it's about $1.75.
Yeah, yeah.
Super cheap.
This case here is $8. And it's got the clip to go on the DIN rail. The full-size box, well, this was $12 and this was $15. You know, it adds up, and you start putting in, well, you know, you start putting these in, they'll cost a couple bucks a piece, and the connectors inside, you know, all when you're all done, you might have $200 in extraneous parts. But the thing is, you didn't burn $400 worth of your time to assemble something that you could that would be robust.
Right.
So Shannon, you said you went to bought these from Amazon. If I went
Yeah.
there and looked for them, what would I look for? What's the product name?
I don't know what this brand is, but type in DIN rail, DIN rail, breaker box,
Okay.
and maybe 6-way or 15-way or something like that, and that kind of specifies the size and gives Amazon a keyword to help it narrow in on it. Again, I'll put
Yeah, if
something
you type
together
in
and post in the forum a whole list of my favorite items.
That'd be neat. And that was the mini breakout board you had the P2 Edge sitting on? Or
There's a
little
mini in
carrier?
here, but I've got the full scale, the full size in this larger box.
Mhm. Cool.
So
Be on
reduces
the
my
lookout for that.
boards and my thought again down to small pieces that I can make hundreds of and just populate them accordingly as the situation arises.
Nice. Thanks for sharing all that.
Thank you.
Everybody's interested in the sources, so yeah, we look forward to you looping back on that. So Johnny Mac, do you want to show us something that's been running for many, many years on a BS1? John is with
Sorry,
us.
I was trying to unmute myself.
It's all right.
Yeah. Yeah, this this is I sent this video to Ken the other day. So most of you know who I am, and what I do is mostly entertainment oriented. So I do lots of LED stuff for movie props and things like that. And one of my occasional customers, and seems to be back, is Disneyland. And I got a call from Disneyland a month or so ago that they wanted me to write them some code for the Haunted Mansion. So for those of you that don't know, so they shut down the mansion for several months to do some refurbishing and fix the outside queue line because it was kind of a disaster. And so now it's reopened. And if you don't live in LA and haven't gone to Disneyland this time of year, what Disney does is an overlay using lots of characters and things from the Nightmare Before Christmas movie. And so they've got some really big animatronics that have, you know, tens of thousands of dollars worth of controls in them, but they have lots of little small tchotchkes that have every processor aside from the P2 that Parallax has made. In the mansion right now, there are BS1s, BS2s, Propeller ones, NSX chips that are running on boards that I designed over the years for them and for others. I was working with another former Parallax employee named John Barham, and we made these boards. Disney was one of our more regular suppliers, but it just made me laugh. And they sent a video. I'm going down to see this Saturday, so I'll try to take better video for later. But if I can share my screen, I'll show you the video they sent. Now, again, they do a Nightmare Before Christmas overlay. And one of the things that they take the trouble to do is they build a gingerbread house that is animated and lit up, and it's actual gingerbread. So their catering people get involved too. So it looks like a gingerbread house, and it is a gingerbread house. the funny part about this is that for those of you who've been through Disneyland, have seen this is in the dining room area, of course, and you're in the Doom buggy, and there's a big sheet of glass in front of you because that's what they use to reflect the ghost images on. It's called the Pepper's Ghost Effect. But they sent a quick video. I'm trying to find Ken the share. Oh, there we go. Right now, can you see my video, my editor? You there?
Yeah, looks good.
Okay, so you can see my stamp editor. All right, so here's the, I don't know if you can see my cursor, but in kind of the lower left area of the screen is going to be where the action is. Look for a couple of Jacob's ladder kind of effects. Now, as I get down here, you'll see the gingerbread house. There it is. That's the gingerbread house on the table. And in the middle, you can see the Pepper's Ghost, or sorry, the Jacob's ladders. And then to the left of them is a dial that is a little animated. It's a little tricky to see. So you can see there's all food attached onto all of this. The Jacob's ladders, each of them are run by a basic stamp 1. So a 30-year-old microcontroller from Parallax is running in this multi-billion-dollar corporation's fanciest display. The dial next to it is running on a Propeller 1 because that dial is controlled externally. So you can see it was moved and stuff. The dial and the lighting for that, all that control comes from a DMX system. So the board that I had built for EFX Tech was called the HC1. So it has RS-45 in and 8 high current outputs and lots of other stuff. The first thing that they wanted to work on, though, was the Jacob's ladders. And they had these basic stamp 1 controllers. They wanted to use all 8 outputs. You can see there's just sets of LEDs that are going on. Although the effect turned out, I think, pretty nicely. It was much better than I expected when I wrote them the code. And so the first time we wrote it, I was just doing straight digital outputs. And then they came back and they said, the lighting guys say they're too bright and we don't want to put new resistors in the lines. Can you fix the brightness? And I forgot that even way back then, the BS1 had a PWM command built into it. And so these guys are not programmers. So it's my habit with them is there's a whole bunch of constants here that they can mess with. What they're going to, in this particular case, I told them definitely to adjust the seed because they have two of the devices there and they just power them up. So because we're using all 8 outputs of the stamp 1, we have no ability to look for a trigger signal. So it just gets powered on. So I told them to change the random seed so that it was different in both so that the randomization was slightly different. And then this level is the brightness so they could adjust the PWM level. And they also set this time, which was essentially how long to go from bottom to top. And all of that sorts itself out here in about 9 lines of code. I found over the years that in the BS1, running the running random multiple times seems to provide more random looking results. But this is the loop that's running those things. So we all get wrapped around the axle with high tech and that, but Disneyland just wants to entertain people. And they're lighting people, and the guys that I work with in their tech department were thrilled at how this all turned out. So they kind of were a little, they called me 4 times last week, said, "You're coming down, right? You're coming down, right? You're coming." Yeah, so I'm going down on Saturday when I have some free time to see it for myself. But as always, just, make people smile. That's the best thing we can do with what we do in our work.
That's really cool, John. It's nice to see such simple code and really a simple application that has huge impact on the
It's
viewer.
one of those things. I always do simple code, but it's providing it some flexibility. And then, I have people on the street sometimes stop me and they'll say, "What are you looking at?" And I'm usually staring at stoplights or crossing lights, just to try to look for the patterns and try to figure out the timing. And with this, you know, we all know from horror movies what a Jacob's ladder looks like. So we thought, hey, it starts slow at the bottom and it gets faster as it goes towards the top. So that code decreases the timing between the steps a little bit. And just with simple kind of using, you know, what does the real world do? You know, it sells the effect, and it's in that fun thing. So I don't know what else, if there's any other parallax stuff in that gingerbread house. I know for a fact there's a P1 and the 2 BS ones, but I know throughout the mansion during this season, there's all kinds of little small tchotchke props that are, you know, light up LEDs and do funny things, and they're almost all basic stamp 1s and basic stamp 2s and propeller 1s. So when I go through, I'll take pictures and I'll get them posted up on the board, because they don't seem to mind me talking about the stuff now. Chip, did you get the SD adapter I sent you?
Yes, I did. Yes.
Okay.
I haven't tried to use it yet, but I've got it.
Okay.
I hope to get to that at some point.
Me too. I hope you get to it too.
Hey, I was just looking at that code, you know, at the time, I didn't, well, the stamp was made in 92, but there would have been ways to exploit things like the watchdog timer on the PIC chip to actually get a good quality random number that we could have at least used as a seed, you know, that would have differentiated all those things automatically at runtime.
You know, one of the things I've done so many programs, literally thousands, for haunted houses and things like that. And it is very interesting that, because so many, you know, I just went to the Halloween show in March, and the controllers that are mostly available are what we call bit bangers. So they're just digital recorders. So somebody presses record and they're pounding on a button and to stimulate an output. And they work, but they're boring. And one of the things that you see is that when people try to simulate randomness by, you know, randomly banging on the button, but as soon as you see that prop operate a couple of times, you're bored with it, because there's not randomness. You see the patterns. Our mind is really interesting that way. We see the noise, we see the repetition really quickly, even when it's supposed to be random. And it gets boring. So when John and I were actively going to those shows, his neighbor in Rockland was a cabinet builder, and John had found this really nice version of a Chucky doll. So we had the cabinet builder make a scale electric chair that fit the Chucky doll, and then we put a pneumatic cylinder on it on the back, so it just moved forward and back. And then we used a basic stamp 1, and we used our audio player that we had made. And at the time, my friend Carmen, who's a professional singer, lived downstairs. So I went downstairs and voiced a bunch of audio. And then we had a button on the thing where you could press it. And then because of the random, even in the stamp 1, it would randomly say some pre-electrocution snarky comment, and then he would get electrocuted. That was the same audio, but what I did is that I knew how long the audio ran, and I had done some testing on the pneumatic valve, and I figured out it took 250 milliseconds to extend or retract. So I set my random values in a range of like 100 milliseconds to 250. And so it never fully extended, or sometimes it would, you know, it was jerking back and forth. It wasn't just the full chunk like the other guys were. And there was a company, when we set this up and people saw it, there was a company that made a $10,000 electric chair with a full-size human prop in it that was boring. It would scare nobody. And they came over and they demanded to know how we made our little desktop prop work the way it did. But they didn't want to get involved in programming. And we said, we'll give you the code, you know, but they wanted to play with the safety of their bit banger. So I you know, it is interesting that my biggest goal in life is to teach people not to be afraid of programming. people not like us, people that are new, because
Right.
there's so much available in our lives, whether we're writing Python or Basic or C or Spin or whatever, it doesn't matter. It's a tool to solve problems and do entertainment stuff.
Right.
So hopefully now that Disneyland is kind of back online, they went through a lot of craziness with COVID. And then, what had sadly happened, I thought it was over for me. Last summer, the guy that I had been dealing with for 15 years passed very suddenly. He was a young guy. He was only 50. And so I had thought, well, okay, I was sad because he was a cool guy. And that was, I wasn't sure what would happen in Disneyland, but then somebody dug up my number and they called. And so it'll be fun to be able to work with them again.
Cool.
So we'll try to get more propellers into the Magic Kingdom.
Thanks, John. Okay, next up, what do we got?
Well, I was on the short thingies queue.
Go ahead.
So I think that was like, I have to give the whole intro for this, but well, or maybe I don't. Maybe I just share the thing, and the thing is obvious what it does. Welcome to whatever this is. The answer is it's some texture mapping code that I wrote.
It looks kind of 3D.
Yeah, that's because it has perspective correction.
Looks like Minecraft, actually.
Yeah, this is some Minecraft textures. I'm just using this texture atlas because it shows off the perspective because it's a grid, right? I can change it to a different texture, but you wouldn't be able to see it as easily. Let's see, load different texture. Would look like this. You can't really see that there's a perspective going on there, right? So that's why I think the Minecraft texture atlas is more interesting to look at for now. It does consist of a lot of purple squares, but oh well. Point is, this fills pixels with textures on the screen. And it does this in, well, anyone want to guess how many cycles per pixel this does?
You can count on one hand, right?
No, it's not that fast.
Well, are you doing a divide at each iteration?
Well, that's a secret. We're gonna get to that later. But ostensibly, yes.
Tens of what?
Ostensibly, yes, but not really. There's some trickery going on.
Well, you can multiply by reciprocals, right? Faster.
Actually not, but anyways, I'm gonna lift the secret. This takes about 26.3 cycles per pixel.
Wow.
That's just that's doing basically the interpolation of the texture, and it's also of course looking up the texture. The texture is 8 bits, so it has to look it up through a palette and then stores it into a 16-bit buffer. And yeah, so that takes apparently 26 cycles to do.
Wow.
Now if I want,
so would that be including any hub access, or is it just like instructions?
this is complete, including the complete. Basically, how much does it take to fill a 320 pixel line divided by 320? The entire line takes like 8,435. I can change my shader here. This is going to be exciting. I can add some lighting into the mix.
Cool.
I can interpolate a brightness value. And this is now just a little bit slower.
The lighting change was dramatic.
This takes now 36.8 cycles. So that's kind of coming somewhat undercutting my estimation that I made some time ago. 40 cycles. Well, this is only if you draw a long span. If you draw shorter spans, it does get closer to 40. And if you draw like only 2 or 3 pixels at a time, it gets really slow. Well, it doesn't get slow, it just has a lot of overhead. But we can do even more because this can't just do like a lighting thing, because it can do any pixel mixing operation that you want. Oops, it might have just broken up because I accidentally scrolled on the capture card, and scrolling is evil. It will resize the window. Anyways, if I wanted to do something else, I can just change some registers, and for the same cost, I can, instead of a lighting effect, I can get a fog effect. It's basically just more like an alpha value that gets interpolated along with the UV value. And as you might have noticed, there's some dithering that happens on top of this because we're rendering into a 16-bit buffer. It needs dithering. Because, right, let's switch back to lighting. This is what the lighting looks like, right? We can also do it without dithering, and it would look awful. Maybe it doesn't show up over video sharing. But
I see. Yeah. Well, now we're seeing different colors instead of pixels being dithered, right?
There's a lot of different bands, and especially in like the purple one, they shift in hue.
Yeah.
And it looks like us. And as if the dithering is enabled, it smooths it out. It gives it a bit more grit as well.
Wow.
We have even more shaders. We've got this one's almost more. I've kind of developed it as like what happens if I do this, but it's actually not that bad, which is this has texture filtering. Like, you know, like a real boy or something.
Yep.
It's all smooth here. Let's change to a different set of parameters that might illustrate the point a little bit better. Yes, this is like really zoomed in.
That's cool.
As you can see, it sort of does this usual sort of linear interpolation between pixels. If you had this set for the regular thing, it would look like this. Just like big square, right?
Right.
But with the filtering enabled, it is very blurry. And as you can see, this also does the lighting. And this is even slower. And as I said, I originally was like, this is just a joke, that it's not actually usably at a usable speed. But this takes 87.8 cycles, which sounds like a lot. But if you think about it, if you have like your 4 cogs working on this, and takes 88 cycles, you actually can fill 14 million pixels with this in a second, which is not a lot, but also not nothing.
Right.
right? So this is actually usable in some situations, and not just a joke. And these runtimes are kind of constant regardless of like hub alignment and stuff, because it all uses the RD fast stuff to read into the pixels.
Now you're showing like one perspective on the whole screen. If you wanted to do something like Doom, which I think this kind of thing is for, right?
Well, if Doom works kind of differently, but if I wanted to do like a game, yeah, I'd have to sort of fill the inside of a shape with a texture.
Yeah.
And that I haven't gotten around to figuring out yet. And then, of course, to make the shape, you have to transform the shape onto the screen from your world database, and then you have to figure out what do you need to draw in each frame. It's kind of
Yeah,
kind of a
no, that's a whole
cascading
other-
thing. So
Is that on a Propeller 1 or a Propeller 2 chip?
it's a Propeller 2. The Propeller 1 doesn't do that many
Multiplex.
colors. It also
Are you
doesn't have.
using the pixel instructions like pix? What is it called?
Yes,
Pix
that's what does the like lighting and fog effect. And that's why you can change what it does. It's because it just changes the instruction that's actually running. So if I said if I change my little set pix thing to the fog mode, it just changes what it is. Now you can kind of see a problem with the fog mode, which is that the dithering is only applied to the fog color. So when the color isn't fogged, you get banding. That's because of how the pixel mixer is set up. Now with the normal lighting mode, what it does is it multiplies the texture color with the light intensity, and then it adds the dither value, which it can do in one instruction, right? Now with the fog, it has to blend between the dither value and the texture color, and the dither value just has the fog color added onto it. Like added onto it once before the drawing starts. So the inner loop time stays the same, regardless of which of these operations can be done. I think there might be some other things that could be done by setting up different values, but I'm not entirely sure what you do with that. But these two options are pretty useful, I think. So yeah, that's that. Now, the trick why this can why I can run this very quickly is that I've using a trick that's actually copied from the old Quake game, and by copied I mean it's described somewhere, and I've actually looked a bit at the code for how they do it. So it actually ends up very similar to how I do it, and that is the idea that let's maybe switch to something that's a bit more sideways. The idea is that instead of doing all the divisions for one pixel, which is kind of, that's kind of nasty, you do the division every 16 pixels, and then you do a linear interpolation between them.
Okay.
So what that does is it sort of very closely approximates what you'd get from doing the division on every pixel, but you're not doing less divisions, which in this case, even though our divider is actually really fast, you have to kind of do a lot of things to get the results from the divider into an address that you can fetch, right?
Oh, well, yeah, are you stuffing the FIFO of the Cortex solver to get this to happen quick? Because you can get a division every 8 clocks that way.
Yeah, you can, but the problem is that this aligns your loop to 8 clocks, and where you grab the result out of it is kind of annoying. And now if you're doing 3 divisions, you're spending 6 instructions just messing with the divider.
Yeah.
Then you have to do 4 adds to increment your values, your 3 values that you're interpolating and your 1/z value. and then you have to actually do a bunch of more adds and multiplies to get the actual address that you want for the text to fetch.
Yeah, I think to use the Cordic and FIFO mode, it's
Sort
good
of-
to have something else prepping up all the batch data, and then something else just simply feeds it into the Cordic and picks it up on the way out.
I did build something that I did build one that did use this Cordic method as which is incidentally like 1/10 of the code and has a lot less overhead on startup, but it looks a bit different because it behaves differently. Well, this can actually, if you change some of the values, this can actually make the texture wrap around properly, which is a big plus. Like, whoop, now the texture repeats. And don't worry about the glitch there. That's just because it runs out of range. But this takes, if you do the same calculation to it, this takes 56.2 cycles. As you can see, this is for the unfiltered version. For the other algorithm did this in, what was it, 37 cycles. So it's kind of like, how much is that? That's like 50% more time to do more or less the same thing. And the bigger problem of that is that it's very hard to like add and remove features from it, because the loop kind of has, you have to kind of do everything at once just to schedule all the Cordic and the RD fast and the other stuff. So that's why I ended up with the subdivision thing. Because the nice thing is that has a lot of like boilerplate that it needs to run through, but you can very easily change out the shader if I can figure out where that is. It's the wrong one. Oh, there we go. So if this, as you can see, if I can very easily swap in the texture filtered shader, I could flop in the one without lighting. I even have one that just does colors. Because if you're interpolating the U value, the V value, and the lighting alpha value, that's 3 values getting interpolated. What else can we do with 3 values? Well, if you just change the shader a bit, we can do a kind of smooth color transition. Now this also has a glitch because it runs out of range. I just pick these parameters by hand, so they often run out of range like that.
Yeah, that's pretty neat.
If you fill them out of your skill. This is basically very simple. This is just taking the interpolated values, sort of reformatting them into RGB, RGB squeezing them, and just writing them out. This is actually the fastest shader, I think, that I've got to show here. This one takes 25.3 cycles. So this one's extra fast. Actually show the code for all of these.
So this is all 320 by 200?
320 by 240.
Oh, yeah.
I can't see the window title bar. That would tell you that it's 640 by 480, but that's just because that's what it captures.
That's 4:3. It's funny, you know, back in the day when everything was on CRTs, these pixels wouldn't have looked square at all. They would have just kind of blended nicely.
Yeah, that's generally what would happen. Well, if you make this less big, it still kind of works pretty well. And as you might have, basically, if you don't do the differing, it looks like, this looks like ass. Colors. You can see this doesn't glitch anymore because it because the differing causes that glitch when it's out of range. But yeah, as you can see the individual like cells now.
Oh, because you were compressing to 565, right?
Yeah.
Otherwise, that would have been without any bands.
Yeah, that would have been, well, there would have been some bands if you like go in close enough, but you wouldn't really notice them as much. Like you can get noticeable banding out of 24-bit. But this is 565, which is very nice because it doesn't take up the entire memory. Like this only takes up like a third of the memory for the work buffer. Which means you can have your like large texture next to it and it'll be fine. Anyways, I'm gonna show the code because it's kind of interesting.
Chip, this Ada does that. I passed host control to you, and I'll stop the recording.
Who has host control?
You do.
Okay.
So thank you. I got to move on to the next thing here.
New share. There we go. That's all. What? Where's the border gone? It's no. Was it sharing the entire desktop? It shouldn't share the entire desktop. There we go. The Visual Studio. Well, this is not Visual Studio. This is just whatever letters VS mean, because it's like the fake version. Anyways, so where's the inner loop for the simplest shader? There we go. That's what the inner loop looks like. You can see it has some startup. Then it runs this, which is unrolled twice, about 7 times, and then it runs this to finish up. And all this does is this, whatever this is, then it does RDFast on the address that came out of that. Then it grabs the pixel. Then it looks it up through the LUT to get the color. Then it RGB squeezes it, and then it just dumps it into a buffer. And then when that is done, it will write it out like this.
Can you go back to where it puts it into the buffer? Words in, right? So
yeah, this is a bit of a trick where it puts 2 words simultaneously into the buffer. You can see this is an alt-I with auto increment result. And we use a set word to sort of grab the 2 words into the result register, and then the result register gets indirected into the buffer and auto incremented. Actually, that's the more complex shader. This is the one that has the pixel mixer in it. As you can see, this is basically the same as the other one. It just has this in it. And that sort of adds but it has this in it, and it also has this in it and this in it. So that's like 11 cycles that it adds. And I think that's actually the result that you get, is that it's like 11 cycles more.
neat.
I mean, this has to be considered. This interesting way of generating the address. Like how do those 3 ads do it? The answer is it's very complicated to explain. How you get from 3 ads into an address that sort of steps through a 2-dimensional array.
Oh, I see what you're saying. Okay, let's see here. So if one of them, let's see. So address. If one of them, if you get two overflows, then you add a whole vertical step, right?
Yeah, that's what text stride is. That's
Subpose address. Oh, so you're using one of them as something to add an extra one now and then. First one generates like a dithering, like a delta delta modulation. Second one incorporates that delta bit in with the AF delta. And then when that thing overflows, it does a big step address. Or a big step to go down to another line.
exactly, yeah. That's ostensibly how it works. But if you think about it, this is already the same address that gets used. So the trick is that the fractional part of the vertical coordinate lives in the upper 11 bits of this address.
Okay.
So it takes kind of advantage of the fact that the upper 12 bits are ignored. The 12th bit we couldn't get because of a complication.
Okay.
Which is basically, just think how this works when when something goes negative, right? Like we want to step in negative directions. Yeah, that's pretty.
So you're using the bottom as kind of a more, part of it's, the bottom part's acting as kind of a linear counter, and the upper part is kind of it's like a separate counter that overflows at a different rate. But when it overflows, you then know to take a stride, a big step.
Yeah, basically the bottom part of AF address is actually an address that gets fetched, right?
Yeah.
And this is why the texture is has a 256 color palette, is because this wouldn't really work if you would fetch anything other than single bytes.
Neat. So you're kind of getting two uses out of one long.
Yeah.
Maybe two and a half with the dither.
Well, the dithering actually happens completely differently. That's why this is unrolled twice.
Well, I mean, I should say delta, the delta modulation.
Yeah, this is basically necessary because you don't want to step whole pixels, right?
Right.
You always want to step a part of a pixel only.
Right.
Oh, well, you maybe want to step more than one, but you don't just want to step 1 or 2. You might want to step 1.5. And that's what does this. Now, the extra spicy thing is that we really don't need the 32 bits of precision for this sub position register. So the bottom 16 bits actually handle the light value. So that's what this get byte does. It grabs the 8 bits of light value, and then they'll get set piffed.
Interesting.
And that is the very interesting shader here. This is called shader textlet. As you can see, that's all of it. It has some extra bit at the bottom and at the top, just sort of, because it has to do this RD fast, and it has to grab it here. So it kind of has to do some pre-run, and then it has to do some post-run down here. We've got the go route version, which just does the colors. As you can see, this is essentially the same thing, except that it uses these two roll words to turn that into a color. Now, this works if you think, what if the base address of the texture is 0 and the width is 256? Then you've got one long that has something, 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 VU, and another long that has something, something, L something. And if you combine it like this, you have a long that has VU, L something, We don't care about the bottom something because that gets deleted by RGB squeeze. And so it just uses the same framework. That's very neat because you can just plug this bit into this, and the actual framework that calls these shaders is da 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 da. Okay, I think this is the top of it somewhere.
That reminds
And
me,
it's
we were
some setup
talking
stuff.
about making an IDE, and so that to increase the like memory of where you are in your code, there could be some sort of like live musical interpretation of the section of code that you're looking at that kind of metamorphoses as you move through your code. So you could kind of know where you're at by sound, just to kind of increase your memory of, you know, what all's going on with your code. Not that it
That seems like an
relates to
incredibly bizarre but interesting idea.
the function of your code, but it helps your brain remember where you are.
Yeah, I usually just put on whatever music I have when I like work on this. Or I put on some sort of stupid video where they talk about something that's like not boring, but also not that interesting. Which is an interesting sort of thing, right? You have to find one that's just barely interesting enough to. So music is usually better. Because like barely interesting is usually something that's, you know, where they're either just rambling about something just vaguely interesting, or it's like politics. Then here's the magic place where well, one of two magic places where it calculates that the delta values. Notice the funny line that say carry bug prevention. That was interesting to figure out. And I don't think I can quite explain why this has to happen.
I understand. Well, you're getting multiple uses out of functions, or out of simpler instructions, and well, you're just kind of figuring out how to use your resources and achieve the objective with as quick as possible.
Yeah, and what the vines actually, this is one of the places where divisions happen. It's actually 16 or something cycles 3 down here. Where like it's done this, but then it just waits on these values because it needs them. And yeah, that's the sort of fast loop. This thing. The problem is you have to set this all up. And even more annoyingly, you have to do because your span isn't a multiple of 16 pixels. Well, sometimes it is, but not always. The first one, not only does it have to do 2 divisions, but the distance between those two is variable because it might be any number of pixels between, well, you only need to do between 1 and 15 in theory. In practice, this is like between 1 and 19 just to keep the overhead down for like when you want to do 17, it would have to do this for 1 pixel, which is not good. So where's the start? This starts up here, and this annoying part is just for doing the first subdivision, which is kind of yeah, we don't like that. Or it does have a lot of free cycles inside, so you could pack something in there. So it's not as bad as it seems. I have a graph somewhere. Not sure if it's the current graph. I hope it's the current graph. It's an annoying graph because I tried doing a different one, but it didn't really work out that well. Ignore the yellow line. The green line is, I must have a version of this that's like slightly older, but whatever. The green line, meanwhile, is the simple algorithm of just the per pixel division. As you can see, it sort of has an asymptotically higher cost. But if you're only drawing a few at a time, then it's actually a lot faster.
Yeah.
It's kind of interesting. Just because it has less setup to do. It does catch up at like 1, 2, 3, 4, 5. So it catches up at 6 pixels.
Wow.
So, you know, if you're drawing up to 5, then you kind of have a problem because it's a bit slower. There's already an optimization for the case where there's only 1 pixel, because otherwise this would be even more. But the very specific case where there's just 1, we have this interesting instruction here where you can skip all of this, where it calculates the delta because it only needs to do 1. So whatever is in the delta register currently just gets used again. Because no one cares what's in the delta. And I guess the last thing that we can show here is the bilinear filter shader, because that one is a bit more high energy. As you can see, there's 3 blend pix instructions to do the filtering, and 4 IF byte instructions to grab the pixels. And yeah, this is a lot of it, but it still has the same little thing here to increment the address. And that is also what it grabs the interpolation factors out of, because they just exist at different points within these longs. Like this just sort of falls out of the other thing if you just change what sort of shader gets called. We also have the other version, the 56 cycle algorithm, just because we can see that again. That's what that looks like. This only needs to preheat the divider here once. Yeah, okay. And then it can basically just do this in a loop.
Okay.
This is a lot shorter than any of the other code. But as you can see, it's kind of less. The reason this can repeat the texture is because it's just these 2 instructions that are just, I don't know what to put here.
Yeah.
I would have had to put either have this stalled for 2 cycles or put a knob in. So you can have this in here. Whereas if you think about how about the funny free ads, you couldn't do that with those at all. So this is the 56 cycle version, which I guess is nice if you don't want to spend all of your program on memes.
I wish we had some way. Well, in practice, it would be fun, but it wouldn't be practical. But it's too bad we don't have any way to like have an FPGA that would be so cheap that we could start with this as a base and then be able to make like special instructions and things to mix in with what we've already got. Because a lot of the stuff you're taking what is possible and you're using it in a way to get what you need, but gosh, a little bit of hardware flexibility on data fields and things could make all this stuff go way faster.
Yeah, I mean, if the main thing that would make it faster is if you could just like if you didn't have to do this qdiff and then this and then also the add to that function, then also the get qx. That's like 6 cycles per component. They're just sort of pissed into the wind for just doing the basic thing.
You know, we need like a multiple instruction kind of machine, because a lot of these operations are not dependent from one to the next to the next. They could be run in parallel, like all those ads. Those 3 ads could be parallelized.
I mean, there's a 4th one up here. It's just sort of up here because, as I said, arranging this loop to fit together like that, it wouldn't. If I wanted to get rid of 4 instructions from this, it would still be a problem to actually get it to fit into 48 cycles just because of the data dependencies.
Yeah.
From this qdiff stuff. So that's kind of why it's useful with the other one that's just out of the inner loop.
Yeah.
Now we just got the RD-fast thing to worry about. Which of course this also does. This can do something that the other one can't, at least not in the way that it currently works. Which is if I made a write 0 on this, and then I made an if not 0 on this, then it would skip drawing any pixels that are 0 in the texture.
Oh, yeah.
Which has its uses. I could write a shader that does it for the other one by just pre-reading the block and then overwriting it selectively.
Yeah.
Well, in that case, you could also do other effects like maybe you can make the block, you can add onto the block or alpha blend onto the block. So that would be useful for all sort of effects. I have some interesting files in my file browser. RD word mybrain.spin2. I don't know what it tried to do here. I think this was stupid. RD word stall test. I think I forgot how RD
You're
word
trying to
works.
measure like which way would be best to arrange your data, maybe.
Yeah, no, which way to arrange the. Sorry, I bumped the microphone. Which way to arrange the RD words? But then I think that was for the bilinear filter. Let's uncomment that part again. That was for the bilinear filter. But then I realized that just doing it with more artifacts is actually just better. As it is in apparently every case. Just artifact in every loop. It's gonna make everything better. I mean, I wonder what this does to like the power
Oh
consumption.
yeah, because really to do an RD fast doesn't take much longer than an RD byte word for long. But if you're looking at contiguous data, it's going to save you a lot of time later on, right?
Well, no, let's just go back to one of the simpler ones. I'm actually just reading a single byte off of it, and then I'm restarting
you're not
it
even
immediately.
waiting. Yeah, you're not even waiting for it. I see.
Yeah, this is just a no wait version.
Yeah.
So that means I can do the RAM read in just 4 cycles. Whereas normally it would take at least 9.
Right.
So that makes it go faster. Quite
Nice.
significantly. But it also requires the loop to be kind of like pipelined like this. Because you have to do the thing while the previous one is still fetching in the background. Anyways, what does this do to power consumption? I don't think it does good things. Because this just constantly causes like spurious reads to happen on the hub RAM, right? Because it's thinking, oh, we're gonna do a big sequential read, but
Yeah,
then we
it's
just grab the
starting to
one
load.
byte.
It tries to load. It starts loading the FIFO.
Yeah, and then it just grabs the one byte. Amazing.
Yeah. It takes a little more juice.
And then we've got, of course, a very cool pixel multiplier instructions. I don't know what happens with those, but they're probably evil. Maybe it takes 7 cycles. Must be a lot of work getting done there. Actually, how does it end up at 7? That's a very odd number.
You know, looking at your code reminds me of like stuff I've been looking at for the interpreter. The instruction set is, I don't know if complicated is the word, but there's like a lot of different ways to do something. So I spend a lot of time coming up with what seems like maybe it is like the optimal solution to solve some little sub problem. But if the architecture was a lot simpler, it wouldn't be so tricky, but we wouldn't get the performance. But the performance that you can gain by thinking like this and arranging your code, so it takes a lot of mental energy, and you get higher performance than if you had a simpler processor with simpler instructions. But I wonder, like, if it's worth it. I guess if you absolutely have to have something that runs fast and you need to be able to do it, you can go through these exercises. But I guess you could also just imagine it's a simpler processor and not think so hard and just do things the more obvious way. But because there is a better way available, it's like you're always playing chess and you're never playing checkers, and it's like mentally taxing.
I don't know. I'm sort of person who actually likes to play chess.
I do too. I mean, it's a lot of fun, but there's a lot of like
I get like people
implementation.
who like, hey, want to play a board game, and then like they've never played chess in their life.
No.
Like how does that happen?
Yeah.
Doesn't like
Yeah.
I first played that when I was like 5 or something.
I can't play chess because it feels like an electrical short. It takes too much energy to try to think about things. And then I've played people who just knew a lot of moves, and that's kind of
Yeah,
like
I mean, if you're trying to like pro level it, then yeah, whatever. But I think that applies to most things. If you like getting sweaty about it, it's probably not worth it.
Yeah.
Whereas if you're just like, oh, we're doing it for fun, we're having a great time, then it's probably good. Well, you don't need me to tell that. It's sort of self-evident when it's good.
Yeah. Complexity. There's all this complexity. I wish it was possible to do stuff without getting into complexity, but it seems like if you want things to be high performance, they're usually going to be complicated.
I think the complicated thing is kind of why it's interesting, right?
Yeah, no, it is engaging. I mean, I could play these games, you know, years on end of optimizing code, but it's sort of like being in a, I don't know, it's like being in some kind of fantasy land where all these things are possible. It's fun to get them working. But I mean, we spend a lot of time on the details of implementation as opposed to, you know, just simply implementing something that's sort of just okay and kind of works, but isn't
that's kind of
optimal.
That's kind of the thing that's arguably wrong with how computers are being used today, I think. Like you see all the stuff that ostensibly kind of works. I say it ostensibly a lot today. But that just kind of works, but not really. And like it uses like 100 times the resources that it really needs to use.
Oh yeah, that's kind of the other, yeah, that's another aspect to all
and
this.
that sort of compounds because someone writes a library that's just okay enough, and then someone writes code on top of that library that's just okay enough, and that probably recurses like 3 times because they all use like a package manager where they can just not even care about all the sort of sub dependencies they're pulling in.
Right. Yeah, they can just.
So the terribleness sort of compounds on itself, and that's how you get. Like, have you ever used like a website like recently? Sometimes it feels like you're back on dial-up because it like takes so long to load. But often it isn't even
Yeah.
like the internet connection that's slow. It's just your CPU is pegging at 100% because it's like trying to pass for like trillion tracking scripts.
Right.
It somehow this even happens with like the ad blocking enabled. So like most of the shitty scripts would be blocked.
You're on a topic now that I'm kind of been interested in, and more than the yeah, there's the tremendous amount of stacks and layers, and it's just crippling the resources, and if you don't think about it and just stuck on other layers. But I think let's get back down to the level, and I think Chip was going for the, well, I find myself down. I love solving these little things and optimizing down to the cycle on the, I'd wake up in the middle of the night excited because I've saved one cycle off of an 11 cycle loop and of an inconsequential function in assembly. But I like that. But getting stuff done, macro stuff, moving things, not physically things necessarily, but projects, and
Yeah, the
doing
macro
good
level.
ultimately. We want to get lifted up out of that detail somewhat. It's entertaining for for a lot of our heads, but and that's,
Oh yeah, it's seductive. It just sucks you in and gets a
yeah.
hold of you, and it becomes all about that.
I like languages like Prolog or data log or inference engine sorts of things, and or even just SQL, where you're not necessarily telling it how to get out what you want, but you're describing clearly what you want, or a declarative language, just broadly. I want this in the end, and the language, could come up with, if not the optimal solution, a serviceable solution without pulling your head into it. And the toggling back and forth between this microcode level stuff and in these physical projects I'm doing, the higher level interfacing with the world stuff. That's why I am trying to reduce the interfaces down to, I mentioned the Arduino kind of nodes at the end. There's a little chunk of microcode there, but then you've got a hard interface. It's just straight up serial. And then back in Propeller land, I'm pulling all these streams of serial streams together and concatenating them into effectively their path, like their file path, where they came from, and dealing with them like that. And actually into a SQLite database where I'm doing most of the processing, but trying to, even I haven't yet, but on the way to, like these Nextian interfaces, these displays that have a serial stream where you kind of describe the interface, and it'll draw buttons up there, and you can put callbacks on them and whatnot, but have that interface drawn dynamically from all the streams of data that come in serially. And you'll know that, oh, well, that's a so-and-so reading, and we can put these on an assortment of displays or plots, but you can also have actuators with buttons and whatnot. But yeah, to deal with that, to move faster on the bigger projects, I'm trying to consolidate and compartmentalize the times where I have to get down low into the code. So maybe I can move faster and everybody can move faster.
Yeah, I'm always kind of running these like ideas around in my head about what can be done to simplify these kinds of problems and get them to go away. But you know, they say there's two problems in computing. The two big problems are naming and cache invalidation, which is, you know, more obscure. But naming is like, Stephen and I were going over my implementation of structures that I had, and what I had were, I had pointers that were disguised as just simple variables, which was the inside out approach compared to how everything else works. You know, normally you have a pointer variable, but you have to accentuate it with some operator to get it to act as a pointer.
Yeah.
Well, my pointer variables were just, they would automatically be like, what would you say, dereferenced or doing what they're supposed to do. And then you'd have to put them in square brackets to operate on the actual pointer, you know, like, and so to me, but okay, anyway, that was, he said, this is completely reverse of how everybody has been taught to understand pointers, and it's going to be a stumbling block. But if it were the first thing that you'd learned, it would actually have been very simple. You know, this is just like an alias. It's like a dynamic alias. But the reason that I did that, looking back, the reason I went that route was not to be unconventional, but it was from naming pressure. You know, because when we do it the longhand way, which is what we're going to do now, where if you want to just, you have to use like a cast of a structure. Like you'll say, let's say you get an address to a structure. Well, you have to dress it up and you say the structure name, brackets, the address that you're, where this thing is, and then you do all your dot members and brackets for indices and all this stuff. Anyway, the reason I had gone the initial route I did was because it just simplified the naming. Because here's the problem. Let's say you have a structure that you want to access, and someone gave you an address to it. Very straightforward. They might give you a byte, word, or long address in a parameter of a method, right? But then you have to say long bracket that address, right? Rather than have the inferred fact that it's long already being used.
Oh, yeah.
And so now we have to say the structure name, which is now going to be superfluous to the address name that you've probably been given, right? Because they're probably going to have similar names. And so by putting that,
right, yeah, yeah,
by putting that all into one name and getting rid of all the structure annotation that, or the pointer annotation, is just like, to me, just simplified the heck out of it. It was an attempt. I was trying to, not realizing, I was trying to solve the naming problem, you know, but it was making things complicated and unorthodox. Not really so complicated, but there were some junctures in code where, you know, you'd have to declare with a caret byte and then a variable, and it would make a byte pointer to something. But anyway, I realized, okay, this is just exploding the complexity, making the whole thing harder to understand. If we just go with like long bracket address or structure name bracket address, and then we stick with that kind of syntax, it's already, everybody already knows it. You can never really go wrong with it, but it does create naming pollution, because it's going to be redundancies. So, you know, always, man, I'm just thinking, how can we circumvent the naming problem by anything other than just more and more text?
Yeah. So Stephen brought you back to straight and narrow here.
Yeah.
Well, it is a stumbling block, and honestly, there's so many other unconventional things going on in here that it becomes
maybe it becomes
difficult. All the simplification becomes difficult.
Yeah,
until
it's just my struggle to figure out how can we add complexity without adding mental burden? How can we add efficiency without adding mental burden? I mean, and this is just in the domain of 7-bit ASCII.
right.
Yeah, just put Unicode support, and then you can name your variable the poop emoji, and everything
Emojis,
will be
right.
good.
Yeah, I could actually like I could quietly implement the entire thing I had planned. And if it wasn't documented, nobody would even know it was there, and nobody would complain about it. You know, in addition to the obvious way of doing it.
Uh-huh.
Well, you know how that winds up. Someone sees where you coded with your secret stuff, and then they're like, "What is this?"
Yeah, I wouldn't want it to be secret. You know, the whole point is that people can use it. But I don't know. Convention can be kind of a trap in some ways.
Absolutely.
Yeah.
I will say, like, one of the challenges I've had are all of the quote conventions that are like in C. There are all these tools and things built around it, and shorthand, and so, you know, certain ways that you can express things that aren't explicit. That you know, such as like an if statement that instead of it actually being encapsulated in curly braces, you just put it all to the side. And it's like, what is it doing here? How does that work? You know, it's like it went back to thinking about it like BASIC. It's like, oh, that's what they're doing. But there's all kinds of little shorthands that are in a lot of these languages that just really make it difficult whenever you run across.
Yeah, I think the thing with C is that no one actually learns C as it's like intended to work, because basically people learn Java first and then they go to C. At least it used to be like the thing. And of course, Java is basically based on C, but it writes very differently. And then they go into C and then they write it like that. But or even like newer language, Java is actually a bad example. But basically, the way that the if statement works in C is that it only guards a single other statement. So having the if without the curly braces isn't the shorthand. It's just that the curly braces create a compound statement.
You mean it will
actually create a
because the curly braces will make it fully evaluate?
No, the curly braces are a compound statement. Everything within the curly braces is one statement.
Oh, you're going to, it's like a scoping thing. You're going down into a.
Yeah, and that's why you use the curly braces on the if, is because you want more than one statement in the if. But the if only does one statement. That's how the language is defined. And we always think about the version without the curly braces as like a weird shorthand, but it's actually the other way around.
And thank God, Ada, for helping me out whenever I came across that, because at that point my brain was melting down. And I'm like, what is this? And Ada's like, oh, it's just, you know, it just is that one thing.
I mean, in Ruby, which I use for a lot of stuff, there's a very interesting shorthand. You can actually put the if after the statement you want to guard. So you can say something like raise if I equals 0 or something, and that will raise if I equals 0. There's also the very good unless keyword, which would be like raise unless I equals 0, which is basically just an if not, but well, that's an unless, right?
Right.
That's kind of interesting. Spin has an if not keyword. Just as one word.
You know why? Because it was simply a bytecode optimization.
Yeah, but the interesting thing is that if you write if not as 2 separate words, then the not is its own bytecode, which is very strange.
Oh yeah, that's how it would be.
I think changing it, not changing it, but like if you had changed it back in the day to unless, maybe it would seem less weird.
Oh yeah. Well, then we also have while and until, right? While and then
While until, yeah.
Unless, if not.
Hmm.
When we've been working on this TypeScript code with Steven, the TypeScript, well, he has like a VSC front end for TypeScript that arranges it for you and colors it and everything. But it also like edits it as you type. Like it doesn't let you put white space wherever you want it. To say you want to make all your comments columnar off to the side, it doesn't let you do that. You know, it's just
That's
always
nasty.
like, you don't like that?
Yeah, that's nasty. And when it's useful when you've just got a piece of shit like that's like poorly formatted and you want to apply it to just that range, like reformat this. That's fine, but normally what happens when you write the code is you sort of add white space to line it up, right? So
Right.
it all lines up with each other. And
Yeah, like we have these
you
table
delineate the
entries that,
different sections and all that stuff, and then you
Yeah.
auto format that and just like makes it worse.
well,
The other
yeah,
thing is just the idiosyncrasy of where the white space is on a particular thing. That actually is helpful, I think, in just finding your way around the code, because every piece of the code looks slightly differently just because of like what kind of weird formatting you did that day, right?
Right.
Just the shape of the code is kind of more dynamic, and that makes it easier to find your place again.
Well, what I'm thinking about, I mean, they did this so that everybody's code kind of looks the same. So, I mean, what we would do as we write code, right? We're playing this chess game. Plus, we want our comments to be in maybe a certain column. So we do all this stuff. So it's all like visual mnemonic for our brain so we can remember what we're working on. But then it becomes stylized like how we want it. So what this TypeScript thing does is it rips out all the stylizing and you just have this straight plain code. I think the idea is that just like it makes people interchangeable, right? So that they don't need the same person looking at it all the time. But there's another effect about this. In my code that we translated, I had all kinds of like, it's spaghetti code, you know, it's assembly. You can loop back, you can do all kinds of stuff. You can break out of the loop in different places if you need to, lots of possibility. And so it's not that complicated, but when we go to TypeScript, it's completely structured. So we have many, many, many sections of code where we have else if, else if, else if, else if, in this giant cascade. And then what was very simple in my spaghetti code becomes like this complete mind bender in TypeScript that we have to revisit way later because there's some flow control problem that we didn't quite get right in the translation. And so it makes like this, I don't know that code, yes, it's structured, but I don't know that it is really any more sensible. But it has to be done that way to be structured. You know, there's no go-to or anything. There's no.
I think the way that these sort of structured things, and like you have to put everything into a function, that sort of thing. I think that sort of constrains the idea of what you can do, because that doesn't really exist on a lower level. The processor just jumps wherever it wants. Well, you kind of on a newer processor, you have to line up the call and the red, otherwise it gets angry.
Yep.
But I mean, you don't have to. It just gets angry if you don't. Like the Intel guy will call you and tell you to knock it off, you know. But in general, you can just like jump around as far as you want, and you can sort of have any structure that seems fit.
Yeah.
Most notably, you can just one thing that you really can't do is if you have some reused block of functionality that you only use in one subroutine, you could put that into its own subroutine. But if you do it in like C, it will sort of insist on using the full calling convention. Whereas if you do it yourself, you know that the value you want is already in this register. So you can just call and return, no like push pop nonsense.
Oh yeah, we had to build, we had to write a lot of like pieces of my code. as methods because we needed to do a conditional based on the complex, like a bit of a complex process to do some evaluations. But in the structured code, we just needed to keep things sane at that level. We needed a singular if. So it forced us to make what in my code was just a little section of code into a whole method that we would call only once, just so that we could say if, then, you know, go into a nested, you know, area or something. So there's a lot of that kind of stuff going on. So I don't know, that to me, it's like squeezing the toothpaste just on some other side. It doesn't really help. But man, if I knew what the formula was for really solving this kind of a problem, I would be all over it. I just dedicate my life to doing that. But it just remains this kind of like enigma that I'm always like feeling the outside of, never getting into the middle of.
Yeah, they've never really. I'm not aware of anyone doing like flow control any differently. Like they invented like C in the 70s or whatever, the 60s. And like the languages that came before that, of course, they probably actually invented it, but no one remembers what APL is or whatever. And then no one ever changed it again. You got some way down the road, someone added closures. Closures are nice. And yeah, that was it basically.
Yeah, I always think, you know, that we got this limitation. 7-bit ASCII is one thing, but maybe, you know, code is also one-dimensional. That's another issue. It does wind up, you know, when you do a carriage return line feed, you do go to another line and begin, but really it's all one-dimensional, but it kind of appears two-dimensional. But I don't know, maybe there's something constraining about a one-dimensional description of functionality or something.
I mean, there was like a disassembler program where instead of just displaying a long list of instructions, it would actually like find the blocks and like display them as a flow chart. What was that? It was like IDA Pro, I think was the name. Let's see if you can find a screenshot of that.
Yeah, you could represent instructions as like little boxes with some functionality kind of, you know, illustrated on them. But then
Have
you can
you done any like Node-RED flow coding where essentially you've got some input, a structure, JSON blob in the various worlds I've seen it, with assorted values, and it comes in and you'll apply functions to that and change the data in it, and occasionally save some off and drop some, and the calculations may create another elements of the data structure that continue to flow through the system. And
like
these IoT systems that are kind of queued up like that because they're taking code from incoming streams from lots of places and processing it on the way, and not kind of batch processing it ever. They have to process it.
Yeah. You're talking about what's called functional programming, right? Where you have an input, a function, and an output.
Mm-hmm.
And that's all you've got.
Yeah. And there's patterns like people will rewrite their code without if statements, without conditionals. Well, the if. Every case that it comes up, it's a switch.
Yeah.
And there's always a known positive output exit at every stage. And I guess it also helps in stack juggling when you're in and out of functions, if you can continually fly constantly straight through the code.
I was reading about functional programming, and they're talking about these things. Some things that are the most obvious thing in a normal language becomes this like weird thing that has to be strangely spoofed in functional languages.
Well, yeah, once you interface with the external world,
Oh, yeah.
you've got to break the system, break the functional
Yes,
system, and
now
things
you have
become
timing.
unpure.
Right. Yeah.
Anyways, here's a screenshot I found of what IDA Pro would look like. This is the flow chart.
Oh, interesting.
So this is ostensibly a disassembler, and it just like, you know, shows you disassembled code as a flow chart.
Oh, look at that. Is that saying, see, it says push OA hex and then pop ECX? Is that actually like more byte efficient than just move ECX comma OA hex?
That is a good that's a good question. Maybe. Why would it do that? That's a very interesting sequence of instructions.
I think it's just to save. I mean, it's crazy on what has to happen. I mean, that's like going to the moon and back to get ECX loaded. But I think the push is an old 8-bit instruction, and it has an immediate version, which 8-bit field, so it's 16 bits. And then pop ECX is probably maybe a 1 or 2 byte sequence. Yeah, it must have been done that way for size efficiency, but that's hardware efficiency is horrible. That's like as bad as it could be.
Yeah, that's but sometimes you can get this sort of bypass thing. I think the newer AMD processors have this where they can bypass a thing like that. Oh wait, you're just reading the same thing that you just stored. Okay, we don't have to go through the whole thing. We can just bypass it into the register.
Yeah.
I don't know how that works out of the cache. Because if someone else at the same time tries to change it, what happens?
It would engage all kinds of hardware. Even if it is cached and whatnot, it's just a lot of monkey motion, but it saves a couple bytes.
Yeah, this looks like the entry point for like a executable.
An API call.
This is calling win main, right?
Yeah.
So this must be like the C runtime or something.
Yeah. Interesting.
Which we probably just found by going at like the beginning of the file. But yeah, flow chart. But also the other thing which I didn't get to talk about, which I screenshot for like a trillion years. So remember the 3000 sprites demo?
Is this? I don't know if I remember this. That's 3,000 sprites?
Yeah, 3,000 of them. Actually, 3,072. That's a lot of them. So anyways, I showed you one of the funny shoot games as an example of why you would actually have that many sprites. I actually made a little example of what that would actually look like. And that sort of ties into what was said earlier about doing something that's like just good enough. Because let's load that demo, which is like, this doesn't actually do anything. This is just like a very crappy mockup. But you can see you can shoot. You get shot out from this like point on the center on the screen. This is like ridiculous amount of sprites that are actually like moving with velocities around the screen. And this is probably destroys the screen capture. But if I can also use a bomb, and it just collects it all into my character. Which is how it does this in the real one. Now the interesting part about this is that when it does that, right, it sort of has to bunch all the sprites into one location on the screen, which is bad because then all the work, it just ends up on those like 4 scan lines.
Oh yeah.
But surprisingly, this does not explode the driver. It just doesn't.
Well, you probably only draw like the first so many and then just quit, right?
No, if this just draws anything. If sometimes you can get the score to like glitch up, but I can't reproduce that right now. It did at one point glitch up the score on the side there. So you know, and I think this is only running at 240 megahertz, 250, 252. Gotta be precise. And
Yeah,
yeah,
I'm
it's
only
just
able to see that at about 4 frames a second.
Yeah,
in
that's what
reality
I'm
it updates 60 frames per second, but this destroys video capture. Maybe if I reduce the capture resolution down a bit. There we go.
Oh yeah,
Now
that's better.
Yeah.
there we go. Now we're capturing at lower resolution. And again, normally this updates at 60 FPS. And annoyingly, there's this green border that zoomed draws around the window, which means you can't see the job meter. Because the actual code that moves the things and like checks collisions and stuff, I just sort of watched something together to get this to test. And like miraculously, this takes like a fraction of the frame time. Like if you wanted to make a full game, it's all you already got everything you need. You just need to add more cases to some switch cases, but those don't take extra time. Like, okay. Of course, if you wanted a real game, it would also have to have some script interpreters or something of the sort to do more interesting patterns, but like that wouldn't take that much time per frame either. So like, okay, you could just do that. Like, see if you can get the code for that. This really is just the bottom of the barrel as far as code is concerned.
It's still pretty
Make
interesting.
the
I'm not a
code.
big arcade gamer, but that's interesting. I like the effect of that, and seems like you could go somewhere with it.
Yeah, I mean, this is just dubiously stolen from that Toho project series that I am strangely obsessed with. Very interesting. But of course, in that one, the patterns are a lot more interesting because they're actually like scripted instead of just doing whatever this is. Like this isn't just this is all the script that spawns the bullets right now. Just these couple lines. It's just the spawn ring function, which is somewhere up here. Oh, this is high end. This has inline assembly. I don't know why it has that. I could have just used one of the function that's in spin for this, but I think I forgot what the name of what it's called, so I just wrote inline ASM. I think that's it. And this then calls another function that looks like this. There's one optimization in here, the one, which is that it doesn't like search the entire array every time it wants to find a free slot. It like remembers where it left off, and this is this eShot rover variable. That's the one optimization that I've done in this. Just the one. And the rest is awful. Like when it draws an enemy bullet, it just does all of this. Is this horrible? Yes. This is using the amazing struct array, by the way. Look at this shot T struct. Totally big. This should probably be word sized, but then it wouldn't move very smoothly. It's kind of annoying. So you have to make it long sized. Oh, actually, I just, my brain just remembered that I solved that problem before. That movement speed over time problem, because you can sort of like integrate this speed at a higher precision over time. But that's a story for another time. Anyways, it just does this. And the version here for the for those round, not round, for those oriented bullets, it does a full one of these modulus operations for every one of them to figure out which frame of the sprite sheet to use. And it just does that. It just does a bunch of multipliers, it does all of this. And it does that like how many times per frame? Cap that I've set is 1024. Maybe 5/12 of them are active in a frame. No, that's not enough. That's not like more like 700 of them are active in a frame or something in this example. I did get it to overflow at some point. Like if I set it to lower value, I think it wouldn't work. So it seems like a lot of them, but it's actually not that many, and that's why you can write real shit code and have it still work, because it only has to run like very few times. There's just nothing else going on. And of course, the good stuff is in this actual driver code. Even that's not that big. I think that whole thing is shorter than the texture map code I showed earlier, which is quite interesting. And yeah, that results in something that looks like a game if you squint. I mean, let's get a real one up for comparison. Where do we have that? It will probably destroy my computer. Maybe if I say destroy my computer, there's a game from like 2006 that I'm trying to load here, but it just won't. Sometimes the computer just explodes when you do things like this. Oh, it killed my capture. That's very interesting. Every time I start like a Windows application, it like resets the P2. I don't even remember setting up the COM port at any point. It just kind of decides to do that every time a Windows application starts. But we can just restart it again. It is fine. Where do we have? Where do we have? There we go. Restart. So anyways, oh no, compositing got disabled. So now you can sort of see a black outline of other windows that I'm dragging over top of the capture window. That's interesting. Thank you, Linux Jank. Anyways, just for comparison, this is what happens in like a real shoot game. If it will capture the window. Oh yes, it will capture the window. Let's go extra, just because extra will make you question your sanity faster. As you can see, this is exactly the same thing, but the background looks nicer. And there's like, the script is more complicated. But really, that doesn't happen a lot more than just like a couple hundred sprites moving around, right? And I forget how to do this part because I'm talking. Oh no.
Is it now? This is your emulator, right?
No, this is just PC game.
Oh, okay.
Ow. Also, I'm playing in like the tiny window, so that's why I suck right now. But you can see how that's ostensibly the same thing. It's sprites moving, right?
Yep.
I say ostensibly a lot today. Sometimes I just say words like that. Actually, instead of trying to do that, I can. This has something cool, which is a replay function. Now, how does a replay function work? It's actually very simple. What if you had a file, right? And every frame that the game runs, you take the inputs that you use to run the simulation and just write them into the file. And then you can read them back out and substitute them for the real inputs. And that's how you get the same situation going again, right? Now, to make that happen, you have to make sure that like the random numbers are the same every time and stuff like that. But that's kind of really interesting. I don't know why, but it's really interesting to me. Anyways, that's what beating the final boss looks like. Because we have it on replay. Yeah, so anyways, you can talk over this while it does that. So anyways, that's the thing. Try to think about how many of these patterns are just like make a circle appear, right? Like that's the fundamental function of, it's like a fundamental function of the script interpreter that's used in this. If I've read like an article of someone like figuring out how the bytecodes work for this, because they do use a bytecode. I said, hey, this is one guy programming this. But apparently that's like a fundamental function. That's just make a ring of bullets appear at this position. And yeah, that's just like a hard-coded thing in the bytecode interpreter. You can also make like little spreads of bullets, like they go in like a little direction. But not in a full ring, but with some sort of angular difference between them. And the other thing that gets a lot of use here is sort of shooting the bullets and then changing them later. I'm not entirely sure how that one works, but I want to say that it's like tags them with like a tag, and then it does something. Okay, all the ones that have this tag have this sort of function applied to them. I'm not sure if that's scriptable or hard-coded. I'd have to think about that. And by think about that, I mean, well, think about what would be ideal to do. It's all very brain. Of course, what this does that the P2 can't do is alpha blending at that sort of speed.
Right.
I think this just requires DirectX 9. I think the earlier one required DirectX 8 with inexplicably with hardware TNL, which is a very weird system requirement for 2002 2D game with like really basic 3D backgrounds. Like, where do you need the hardware TNL? Presumably it was just easier to make it that way. But like, you could buy in 2002 a graphics card without hardware TNL. Multiple. Like brand new releases. Like, that was not a standard yet. But I think like the Power VR cards had like a feature where you could say enhanced TNL, they called it, which is basically just do the TNL in the driver and pretend that the card has hardware TNL. So that weird games that like really want hardware TNL just shut up. And this is presumably the exact use case for that. Well, this requires like something more high energy. Notice that that's also just rings, right? It's just like there's rings over multiple frames, and that's how that pattern gets created. And that's why create ring is a script interpreter function, like a dedicated bytecode. Anyways, that's like the end of it anyways. It just takes like forever.
All right. I should probably get going myself here. It's about 4 o'clock. If you guys, is there anything else anyone wants to talk about today?
Oh, I think I've showed off all the stupid things.
And it's good to see. All right, well, let's close it up then, and we'll look forward to seeing you guys in a month. And I should have we should have a new tool out by then with the structures. And after all that, I want to get back on the self-hosting thing.
The self-host, the self-host, the self-host.
The self-host. It's one way around all these problems we're talking about, but it requires a keyboard, a mouse, and a monitor. Isn't it kind of funny that none of the systems will let you use them as such? Like, look, I'm not going to bug your drive or get in your network. I just want you to be a screen, a keyboard, and a mouse. That's all I want you to do. But I think that's like that's verboten.
Yeah, it's like you have to like do all sorts of things.
Yeah,
I mean, you kind of get it from like a web browser, but that's kind of like severe brain rot that you have to do to get anything in a web browser.
Right.
I wondered what you could do with like a QR code, like or good old fashioned come on, I can't say modem, but yeah, an audio path from a cell phone, or utilizing the student's phone or screen, flashing pixels. I know somebody was doing that, programming a device with alternating pixels on your screen to bypass, get like a 2FA and
yeah, that was actually, I've seen something like that, where it basically just hold it up to the screen and had like 2 photodiodes, and it would use that to sort of as like a clock and data, and then it could like reprogram the device.
Yeah, that's right. Like,
well, I don't think it would upload full firmware over that, just like the little config strings, because the actual device has like no button.
There was a game show in the 80s in America where you could buy this at-home thing. At the beginning of the show, they would slightly modulate the brightness during the intro of the show, and the device in your lap would pick up a bit stream and then begin a timing counter, and it was coordinated in time with the show so that you could play along, and it knew the answers when it was time for the answers to come up.
that is so cool.
And that was a long time ago.
Yeah, to have an order of magnitude of mastery over the network so that you could sneak that in right in plain sight. It's awesome.
Yeah,
You
it was.
wouldn't- you would never be able to do that today because some idiot wants to like shove ads into the program from like the bottom of the screen
Yeah.
that mess everything up. Like
Right.
seriously, you these days on TV, it's like crazy. You're watching like a movie, and then there's like a banner ad that slides in from the bottom. Like what the fuck?
Yeah. Well, keep refining. I was loosely listening for a little bit of that video driver, and I appreciate the mental energy that goes into making things super fast. And it also becomes better from a security perspective later that it's hard for someone to impersonate you if it's screaming fast.
Oh yeah.
Because you can resolve an answer faster than some bloated program. And one thing I wondered about with the interpreter, this from the very beginning of the live form here, was when you're using different interpreters to compile code, are they generating the exact same binary, or are there some nuances?
I could be doing different, like in FlexSpin, he has his bytecode. He can compile your code down to bytecode, but he will only pick the bytecodes that you're using. I mean, he'll assign those to 8-bit values. And so it's different. And then in the other case, he's just compiling straight into assembly language. So there's all kinds of different interpretations and like modes in which things are happening.
I mean, how do you begin to test whether your compiler is good? It's just so difficult.
You can't. You only know when something goes wrong and you notice it and then you identify what's causing it and you fix it.
I mean, sometimes there's bugs in like the really big compilers as well.
Yeah.
So it's not like that's a one-off. I mean, FlexSpin has like wonky bugs all the time. I think Chip's compilers have been a lot more bug-free. I don't know why that is. They're sort of conceptually simpler, of course, because Spin as a language just kind of directly maps into bytecodes.
Mm-hmm.
Whereas a lot of the bugs in FlexSpin just happen either somewhere in the how do we translate ASTs into something that into assembly, like this so some journey that goes from like the text input gets turned into tokens, the tokens get turned into an AST, and then the AST gets turned into the assembly instructions. Well, first the AST is pre-processed with some stuff because some things just are weird in the AST when they come out of spin parser, so it needs to fix them up, and then it goes and gets turned into assembly, but there's just a lot of moves and a lot of temporary registers involved. So then it goes into the optimizer, which removes all the nonsense, and then it has to get assembled, which it does by converting each instruction that the optimizer puts out into text and saving it into a different file. And then it loads that file, that goes for the spin parser again, and gets output like a dat block into the final binary. And I think there has been I've witnessed a bug in every one of these stages.
Is that right? Yeah.
Which is quite remarkable. Like there has at one point been a bug in the function that converts the internal optimizer instructions into text, which is like a typo.
And it hides out because nobody's using some obscure.
Basically, it was like one of the weirder type of conditions.
Yeah.
Which the compiler wouldn't auto-generate, and so you'd have to like explicitly put it into like inline assembly to notice that. But eventually,
some way that we could, stress test things better.
Yeah, eventually, I added the ability for the compiler to use pretty much every condition code, because initially it just had a list of condition codes that was completely disconnected from the actual bit patterns, and then I changed it to be the bit patterns, and then you can do interesting things like combining the conditions. So if you have a separate C and Z test, you can still have one instruction that's conditional on both.
Yeah, no, the
Which is
combination
very
is endless.
It's very obvious if you're writing assembly yourself, but it wasn't obvious to the compiler that was a thing it could do.
Beautiful, beautiful progress. And yeah, I'm on vacation on the West Coast looking at the Pacific Ocean, so I'm about as close to California as I ever get.
You're away from the choo-choos.
I'm away from the choo-choos. Haven't had my work boots on in over 2 weeks, so I'm detached. And yeah, we're gonna play with a little secret P1 project here in the next couple days. Some old code.
Secret.
Yeah. Well,
Cool.
this country's weird. Yeah, one day when we're not recording and it's late and I'm weak, I'll tell you all about it.
Hold on a second here. Let's see. Stop recording.
There you go.